Hello everyone, I am Karan Mashru. Welcome to this video. So in this video we are going to discuss solution of the problem of the day, that is shortest source to destination path. First of all, let us start by understanding the question. What does question say? It says that given a 2D binary matrix A, zero-based index of dimensions n cross m. Okay, so we are having a 2D matrix which is binary, which means that the entries in the matrix will be either 0 or 1. Okay, and the dimension is n cross m. Find the minimum number of steps required to reach from 0, 0 to x, y. So we need to find the minimum number of steps to reach from source 0, 0 to suppose destination, which is something x, y, which will be given in the question. Okay. Note you can only move left, right, up and down and only through the cells that contains ones. Okay. So first of all, if we understand this question a bit, what is given is that we are given a 2D matrix which is of size n cross m, right? And this is a binary matrix, so all the values will be either 0 or 1. Now we need to find the shortest distance from 0 or the minimum number of steps to reach from 0, 0 to x, y, where x, y will be given in the input. Okay. Also, from a particular cell we can only move in 4 directions, that is towards upwards, towards right, towards bottom or towards the left. And we can only move in the cells whose value is 1. For the cells in which the value is given as zeros, we will consider them as blocked. Here it is said that we can only move inside the cells which are 1. So the cells which have value as 0, we will consider them as block. So we need to find the minimum number of steps to reach from 0, 0 to x, y given these conditions. Okay. If we move further, what does it say? Here an example is given when n is equal to 3 and m is equal to 4 and the input is 1,000, 1101, 0,111 and x is equal to 2 and y is equal to 3. If we understand this, what is given is that if we look at the example, it's 1,000, 1101, 1,000, 1101 and 0,111, 0,111. And this is our binary matrix which is given, and x equal to 2 and y equal to 3. This is our destination cell. So this is 2, 3. This is the source vertex 0, 0. We need to find the minimum distance to reach from here to here. The output given is 5. It is 5. So how it would have been? Here this is the first step, this is the second step. From here this would be the third step, this would be the fourth step, and this would be the fifth step. In this way we will get answer 5 for this question. I hope you understood it. Okay. Similarly, below another example is given, and here it is said that we need to complete this function and do not worry about the input. Also, one important thing which here it is said that if the value of the cell 0, 0 is 0, that is a of 0, 0 is 0, which means that the source cell is blocked itself, then we need to return -1. And also if it is impossible to go from 0, 0 to x, y, then we need to return -1. So if in case we cannot reach to x, y from 0, 0, we will return -1, otherwise we need to return minimum number of steps. The expected time complexity is n cross m and the expected auxiliary space is also n cross m. The constraints are given here. Okay. So now if we talk about the concept part, how we will solve this question. See, here what we are given is a 2D matrix and we need to go from 0, 0 to some cell x, y. We need to find the minimum number of steps. Can we say we need to find the minimum number of distance, where each step would be 1 unit distance? Okay. Now when we talk about minimum distance from one point to another, these type of questions we solve using we solve in graphs. So can we convert this 2D matrix into graph and then think further? Yes, definitely. How can we convert this 2D matrix into graph? See, suppose this is the 2D matrix which I am given, right? Now from a particular cell, it is said that we can either move top or right or bottom or left. Suppose this center cell is A, okay, and this cell is B, this is C, this is D and this is E. Then can I say A is connected to B, A is connected to C, A is connected to D and A is connected to E? I will consider these cells in the 2D matrix as nodes, and how will I get the edges? All the 4 adjacent edges are I can say they are connected to the particular cell, and we can assume an age between them. Okay, and we need to find the minimum number of steps, so I can say the age weight would be 1 unit for all the ages. So in this way, this 2D matrix will be converted into a graph. Now I am given a cell 0, 0, which is a node of this graph, and I need to find the minimum distance to reach to a particular node x, y. So how can I find the minimum distance? There are multiple algorithms, but here, since the age weight is same, that is 1 unit for all the ages, I can use breadth first search. What does breadth first search do? It traverses level by level. So initially I'll pass the source vertex, I'll start traversing this graph from the source vertex using breadth first search, and I'll mark the distance as 0. Then further I'll traverse to the next level, I'll mark all the vertex at level 1 as distance 1, and so on. And after I finish traversing using BFS, I'll get the distance of the vertex x, y from 0, 0. I can do in that way. So now let's look at how we will implement it. As I said, we first we use the queue to traverse the graph using breadth first search. We enter the source node and mark its distance as 0. Then we traverse all the adjacent nodes. Then we push all the adjacent node to the source node inside the queue and traverse them. Then further traverse the next level, and so on, and accordingly mark their distances. So what I have done here is, this is the function which we needed to complete, and in this I have taken a 2D matrix of n cross 251, in which I will be storing the minimum distance of all the cells. Okay, and I have taken some variables. Initially I have marked all the distances as -1. Okay, then if the source vertex is blocked, that is 0, or the destination vertex is blocked, that is 0, I'll simply return -1. If it is not so, then I'll call the breadth first search function. Okay, now this is the breadth first search function. First of all, I have taken the queue. I have taken a visited boolean array of n cross m, which will mark whenever a cell will be entered in the queue, we will mark it as visited, which we do in breadth first search. Then there are some variables which we will be using. Initially I have marked visited equal to false for all the cells. We will be starting with the source vertex 0, 0, so I have pushed it in the queue, marked it as visited true, and the distance of that is 0. Then what I have done here is, while queue is not empty, now what I need to do is, I'll take the first element of the queue, traverse the adjacent cells to that particular cell if they are not visited before. So first of all, I need to take the first element of the queue. So I have taken it using RC. R denotes the row number, that is q dot front dot first, and C denotes the column number. Then I'll pop it out. Okay, then I'll need to traverse the adjacent cells to R, C. Okay, now look here, what we have said is, suppose this is a node RC. Okay, we can traverse in 4 directions. What will be the coordinates of this cell? Same row number, but column will increase by 1. Coordinates of this cell would be, row will decrease by 1, column would remain same. Coordinates of this cell would be, row will remain same, column will decrement by 1. And what will be the coordinates of this cell? Row will increase by 1 and column will remain same. So if I add I to R and J to column with the combination I equal to 0, J equals to 1, I equals to 0, J equals to -1, I equals to 1, J equals to 0, I equals to -1, J equals to 0, I'll get all the 4 adjacent cells. That is what I have done here exactly, because these cells are connected to it. Initially I equal to 1, J equal to 0. So we are now checking whether the R plus I and C plus J cell is visited before or not. Okay, if it is not visited, we'll visit it because it is adjacent or connected to R, C. First of all, I need to check whether it is in the given constraint. So R plus I must be greater than equal to 0 and R plus I must be less than n. Similarly, C plus J must be greater than equal to 0 and less than the maximum number of columns. If it is not visited before, so if it is visited is false, and if its value is 1, okay, I can only traverse the cells whose value is 1, then I'll mark it visited as true. The distance of R plus I, C plus J equal to distance of R, C plus 1. Okay, you understood this? Suppose here is our source vertex 0, 0. The minimum distance, what does this distance 2D vector denote? 2D array. It denotes the minimum distance from source to that particular vertex. Suppose from here to here the minimum distance is 5 and this is 1 unit. Then what would be the minimum distance from here to r plus 1 comma c, from source to r plus 1 comma c? 5 plus 1, that is 6. So that is what I am here doing here exactly. Distance of r plus I, c plus c equal to distance of rc plus 1, and I'll push it into the queue for further traversal. Now let's move to the next slide. So here I have traversed the graph further by taking I equal to -1, j equal to 0, I equal to 0, j equals to 1, I equals to 0, and j equals to -1. Okay. Now we'll just dry run it on the given example. So here the given example was 1 0 0 0 1 1 0 1 0 1 1 1. So I'll just write down the distance 2D array, how it would be updated. So it's 1 0 0 0. Initially the source vertex will have distance 0, other all will have -1, right? Then when we will do breadth first search, see, this is 0 and this cell is connected to it, so this will become at +1 distance, this cell. Then from here it will go here, in breadth first search, so this will become +2, this is the distance, right? This will become +3. Then from here it will go here, so this will become +4. From here it will go here, so this will become +5. And in the BFS it will also go here and make this +6, but we need to return the distance of this, it is +5, so we will return that, which is our required answer. In case it was impossible to reach here, it will remain -1, else these cells are, and we will return -1. Now let's run this program. So I'll pass the code, I'll submit it. Okay, so we have passed it completely. What will be the time complexity? Time complexity for breadth first search is we go of number of nodes plus number of edges. What is the number of nodes? It's n into m, that is the dimensions of the given 2D matrix. What is the number of edges? Each cell is connected to 4 other cells, so I can say each cell have at max 4 edges, so I can say 4n into m, which will ultimately be big O of n cross m. And what will be the space complexity? It will also be big O of n cross m, because we are taking a 2D matrix like visited and distance of size n cross m. I hope you have understood this question completely. Thank you.